Hello everyone, welcome to the introductory tutorial for OpenBio version 1.0. The purpose of this video tutorial is to familiarize you with the basic structure and functionalities of OpenBio so that we can help you hit the ground running and minimize your startup time. So let's begin with what is OpenBio? Well, OpenBio is an easy-to-use modeling and simulation platform that's tailored to biologists. And we stress the point that it's tailored to biologists because everything about OpenBio has been designed to make it easy to use and relevant to answering biological questions. The overall functionalities of OpenBio include creating models, importing models, simulating models, viewing and exporting results, browsing signal flow via the animated flux diagram. And what I mean by signal flow is how the concentrations of certain species within the model change as a function of time, or how certain reactions become more or less active over the course of the simulation. You can also perform more sophisticated analyses like global sensitivity analysis, where you can determine which parameters are the strongest and most important controllers of the model's output behavior. Parameter sweep, which will allow you to sweep over various values for a given parameter when the exact value may not be known, and lets you analyze and compare the effects of systematically changing certain parameter values. Also, we've included multi-start parameter estimation, which allows you to adjust the values for given species and rates in the model so that the model's behavior becomes similar to that of experimental data. So now that I've just told you some of what OpenBio was designed to do, let's go a step deeper and look at how OpenBio fits into a typical workflow of a modeling group. Now, modeling workflow is something that we as scientists don't often talk about, probably because the field's so young and standards for building, simulating, and analyzing models haven't yet been worked out. Often we find that groups build models using one method or program and then manually stitch them together with the next program for simulation and then write some custom scripts to connect simulation results to analysis programs, etc. What we've tried to do and depict here is what we found to be productive and coherent modeling workflow and how OpenBio can be integrated into that. So first, notice there's 5 main steps in the modeling process, moving from left to right: model generation, simulation, model analysis, results, and insight. You'll notice that at each step of this process there are numerous options available, and which one you'll choose is really a function of the modeling and the project goals that have been laid out. For example, for model generation, one can choose to build a model using a graphical drag-and-drop methodology, or perhaps a tabular format, or even a much newer and cutting-edge methodology such as rules-based design. The point here is that we've engineered OpenBio to integrate with all of these methods. We don't see OpenBio as a replacement for all of these good technologies, but rather an integrative platform that will work together with the best technologies. Thus, OpenBio can import SBML models from a variety of other programs typically used to generate models. Once the model has been generated or imported, then we can use OpenBio to perform the simulation and go on to do different model analyses based on the ultimate question to be answered. Again, during the model analysis step, there are a variety of methodologies available, and which one you choose will depend on the model and the goals for the project in question. Following simulation and analysis, we must then view the modeling results, often in a variety of different graphs and formats, to begin the process of extracting insight from our modeling effort. The simplest way to view results is through the built-in viewer within OpenBio. However, for more customized result viewing and graphing options, we also provide access to other programs such as Excel and MATLAB output. Again, we chose not to reinvent the wheel here, and we made OpenBio compatible with the programs that people like to use most. Finally, the scientist doing the modeling will extract insight from these results, be it hypothesis-based, where we allow the model results to point us in a general direction for further experimental follow-up, or experiment-based, in which we've acquired data, fit the model to that data, and then use the model to make more sophisticated predictions in case studies. So now I've introduced you to the program, what it can do, and how it might fit into a modeling group's typical workflow. I'd like to start the software demo and show you around.